Alright, so I think this is recording. Let's take a look at these composite functions. Remember that you take the sine or cosine of an angle and the output is a ratio. When you're talking about inverse functions, the domain and range switch. So the input for inverse is a ratio and the output is an angle. Alright, so make sure you can keep that clear. Now, when we do this inverse sine, we know that it's either going to be quadrant 1 or quadrant 4, the right half, the unit circle. Since this is negative, I'm down here in quadrant 4, so I draw my reference triangle with the right angle, always with respect to the x-axis. This is theta, and that's what this inverse sine of negative 4/5 is this angle theta. So let's call this negative 4, 5, and by the Pythagorean theorem, this is 5 squared minus negative 4 squared, which is 3. So remember that this represents an angle, and I'm letting that angle be theta. So it's asking me to determine the cosine of theta. This information on this inverse sine allowed me to complete the sides of the triangle. To now I can tell you the ratio of cosine of theta is 3/5. And it makes sense that that's positive because in quadrant 4 the y-coordinate's negative, but the x-coordinate is positive. So there's my final answer of 3/5. Let's go on to the next one. The inverse cosine, think quadrants 1 and 2. Since it's positive, it's over here in quadrant 1. This information allows me to fill out 2 of the 3 legs. 3/5 cosine is the adjacent, 5, let 5 be the hypotenuse, and then of course this is a 3, 4, 5 triangle. So this is the tangent of theta, because this, we're letting it be theta, and so it's the SOHCAHTOA, it's the opposite side, the length of the opposite side divided by the length of the adjacent side. So our final answer is 4/3. Again, inverse cosine, think quadrants 1 and 2. With the ratio being positive, it's in quadrant 1. The length of the adjacent side, let's let it be radical 15, the hypotenuse 8, and by the Pythagorean theorem, we've got 8 squared minus radical 15 squared. So the radical goes away, and we've got 64 minus 15, right? Which square root of 49 is 7. Alright, this is theta. That's what this is equal to. So this is really asking us to determine the sine of theta, which is 7/8. And that's our final answer. The inverse tangent uses the right half, quadrants 1 and 4. The ratio is positive, so I'm up in quadrant 1. Tangent is the length of the opposite side, opposite to angle theta, and let 7 be the adjacent side. And by the Pythagorean theorem, if I take 7 squared plus radical 15 squared, 49 plus 15, 64, which we just saw was 8. Yeah. Shrink that, move that out of my way. This, I'm letting it be theta. So So this is the same as determining the sine of theta, and the sine of theta from our triangle is radical 15 divided by 8. This time the tangent's negative, and I'm going to think of negative 5 as negative 5 divided by positive 1. I'm down here in quadrant 4. With this down is negative, so the opposite leg is negative 5. The adjacent leg, adjacent to this angle theta, is positive 1. By the Pythagorean theorem, negative 5 squared is 25. 1 squared is 1. 25 plus 1, take the square root of 26, and there's our hypotenuse. We're letting this inverse tangent be equal to theta. So this is the same as asking us to determine the cosine of theta. And 1 over radical 26 needs to be rationalized, which is radical 26 over 26. And there's our final answer. Alright. Inverse cosine, think quadrants 1 and 2. Since it's negative, it's in quadrant 2. The adjacent leg, let it be negative 2. The hypotenuse, let it be 3. From the Pythagorean theorem, the length of this missing side is the square root of 3 squared minus negative 2 squared. 9 minus 4, this is radical 5. So, since this inverse cosine is theta, this composite function is asking us to determine the tangent of theta, which is radical 5 divided by negative 2. Now that negative sign, you can put it up in the numerator or out in front, or just leave it where it is. That negative sign, remember that the opposite of the square root of 5 over 2 is the same real number as negative 5 divided by a positive 2, or a positive radical 5 divided by a negative 2. So the opposite of this, or negative divided by positive, or positive divided by negative, this is all the same number. It doesn't matter which way you present it. There's not truly a preference. So on to the next problem. Alright, inverse sine, we think the right half, quadrants 1 and 4. Since it's negative, let's place our triangle in quadrant 4. Call that theta. Put the negative sign going down with negative 2. The hypotenuse, always make it positive. By the Pythagorean theorem, this side is 3 squared minus negative 2 squared. 9 minus 4, square root of 5. We're letting this inverse sine of negative 2/3 be theta. So we're being asked to find the tangent of theta, the opposite over the adjacent, rationalize the denominator, and then we'll be done. I'm listening to the Bob and Tom show. Alright, so there is my final answer for number 7. Inverse sine, we think the right half of the unit circle, quadrants 1 and 4. With it being negative, let's draw our triangle down in quadrant 4. Call this theta. Make the negative be with negative 2 and have it go down, and have the hypotenuse be positive. By the Pythagorean theorem, this length of this missing leg is the hypotenuse squared minus this other leg squared. 9 minus 4. Radical. I didn't copy the same problem over. Tangent. Okay. So this guy is theta, and the cosine of theta is the adjacent side divided by the hypotenuse, and that's our final answer. Inverse tangent, let's make this 3 as 3 over 1. We could make it any ratio that's simplifies to 3, but the easiest, I could say 9 divided by 3 or crazy numbers, but 3 over 1 is the easiest. Inverse tangent, think quadrants 1 and 4 since it's positive, up in quadrant 1. And by the Pythagorean theorem, the hypotenuse is the square root of a squared plus b squared, 3 squared plus 1 squared. 3 squared is 9, 1 squared is 1, 9 plus 1 is 10. This is our angle, so we can replace that. Secant is the reciprocal of cosine. Since cosine is 1 over radical 10, the secant's radical 10 over 1. And there's our final answer. The inverse sine, think quadrants 1 and 4. Since it's positive, think quadrant 1. The opposite leg, let's let it be the numerator, 3 radical 5. The denominator, let's double check that what is the magnitude of 3 times square root of 5? 6.7. See, it has to be smaller than 7. The hypotenuse needs to be the longest side, and for a second I was worried that 3 radical 5 might be bigger than 7, in which case that's not the domain, and this would be undefined. But we're good. By the Pythagorean theorem, let's find the length of this missing side. So what do we have here? 49 minus, I forgot to square that. 9 times 5, 45, right? Because the radical goes away, and that's 5 times 3 squared, which is 9, 45, and that's 4, and the square root of 4 is 2. All right, so we are letting this inverse sine be theta. So they're asking us to determine the cosecant of theta, which is the reciprocal of sine. So this is 7 over 3 radical 5. We need to rationalize that denominator. So we've got 7 radical 5 over 15 as our final answer. Hey, that's it. Hope that helps. Talk to you later.